In this episode of KubeFM, we're joined by Radek, who's the head of engineering at Aleno. This episode is a deep dive into a real migration from AWS, ECS, Fargate to Kubernetes. What broke, why it broke, and the concrete fixes that made the platform stable. We start with the constraints that forced the change. Spot capacity failures in ECS and an unexpected entry point into Kubernetes through CI, scaling self-hosted GitHub Action runners with the GitHub ARC operator. Radek then walks through the production setup. Multi-environment clusters, a full observability stack, and a GitOps workflow using Flux for infrastructure changes, and Argo CD's UI to make deployments accessible to developers. We also cover production-only edge cases, DNS cutovers, autoscaling limits, Nginx rules dropping real traffic, VPC peering gaps, and the memory realities of running Meteor.js and WebSockets on Kubernetes, including allocator changes that reduce memory usage by around 20%. If you're migrating from ECS to Kubernetes, this is a grounded look at what platform work actually looks like in production. This episode is sponsored by LearnCube. Since 2017, LearnCube has helped Kubernetes engineers from all over the world level up through Kubernetes courses. Courses are instructor-led and are 60% practical and 40% theoretical. Students have access to the course materials for the rest of their lives. Courses are given in person and online to groups as well as to individuals. For more information about how you can level up, go to learncube.com. Now, let's get into the episode.
You're tuned in to KubeFM.
Radek, welcome to KubeFM. What 3 emerging Kubernetes tools are you keeping an eye on?
To be honest, there's not really that much. I'm looking out for some improvements to the tools that we are currently using. So I'm looking up, let's say, for the new things coming to Argo. I saw a couple of things regarding workflows. I saw a couple of things regarding Carpenter. And besides that, nothing really.
Fair enough. And for people who don't know you, can you tell us a little bit more about what you do and where you work?
Yeah, so I'm the head of engineering at Aleno, and we are creating software for restaurants. And that's basically my day-to-day job. I also work at the university part-time because I'm finishing my PhD, which is taking out of time as well. But then my day-to-day is mostly about just creating the application as it goes. So creating features, fixing bugs, all that stuff. And there is some infrastructure here and there, but it's mostly about optimizing costs and also taking care of the new features that we release so they also work quite well on a daily basis.
Okay. Since you did mention that you're studying for your PhD, as you said, that does take up a lot of time. But if you can just summarize in a short period of time, what are you getting your PhD in?
So this is mostly about games. So games, not as in like computer games, but like the games theory, simulation. Yeah, you can read more on my blog if you want to. I don't want to, let's say, dive very much into academics in here.
Okay, fair enough. And how did you get into cloud native?
So how it worked for me is that when I started working as a software developer in general, we were working with, let's say, self-hosting tools, we would call them today, but basically we just had like a whole application made up of, 99% just scripts that were just copy-pasting source code and then running mostly PM2 for years. Then the era of like cloud hosting with all sorts of like Heroku and things like that started. And then at some point when we were just growing as a company, we just needed something, let's say, more reliable, more scalable, or like more approaching to our needs. We started working with Docker, and it was ECS for a long time, and then at some point also Kubernetes.
Okay. And what were you before cloud native?
So before, as I said, mostly PM2 and like very, homemade scripts here and there. It was Ansible for some time, and I don't know if it's cloud native or this is too old to call it like that. But yeah, mostly PM2 and then Docker.
Okay. And, the Kubernetes cloud native ecosystem moves very quickly. What works best for you to stay up to date in terms of resources?
So what I do is I have a very long list of subreddits subscribed via RSS, and I read them, let's say, weekly. Plus, I have a very friendly and very up-to-date DevOps at hand, and he is keeping up with all of those things and just pinging me, hey, something new came up, something new is there. Plus, if you really want to have like the exec summary, I recommend to signing up for the newsletters or also via RSS to the big platforms you're using. So for example, AWS releases, this is quite nice because the title often, let's say, indicates enough if you want to read it or not.
If you could go back in time and share one career tip with your younger self, what would it be?
First of all, don't hesitate to asking tough questions. even if it's for people you are afraid of. So for example, if you're talking with your boss and you're having some problems, just do it. Or if you're having some troubles with, I don't know, you're stuck at some technical issue, just go to the person who may have the answer, even if you think they don't like you, and just ask it. Because it may be the case that it's not only you having the problem, it can be someone else having the problem as well. And if no one in your area knows it, then just, I don't know, file an issue on GitHub or try Reddit or something else, and just, try to pick someone else's brain.
As part of our monthly content discovery, we found an article that you wrote titled Carpenter at Beekeeper by Lumaps, Fun Stories. So your team recently completed a migration from AWS ECS to Kubernetes. Before we get into the journey, what did your infrastructure look like before? And why had you originally chosen ECS with Fargate?
Yeah. So for us, ECS was a very easy way of starting with, let's say, moving our application from some proprietary platform to, let's say, something less pinned to a single vendor. So what we did is we just started with creating a Docker image for our application, and we just went for something that can just take the Docker image for us and just handle the autoscaling itself. So ECS was there, and it was working for many years for different projects we were working on, like because different people on the team were working on different projects in the past, obviously. And we just went with that, and it was serving us quite well for a long time. So we just created a couple of clusters. So let's say one cluster for the production, a couple of clusters for the test servers, separate clusters or like separate tasks for sidecars. Like for example, we had some, I don't know, API gateways, some containers that synchronize data between databases, things like that. And then the application, of course, configured the autoscaling rules, networks, like the basic stuff, and rolled it out. And it worked pretty well for quite a while, so we just let it be, and we didn't touch it for, I think, at least a couple of years.
Spot instances saving 65% sounds great on paper, but I understand things weren't running smoothly. What started breaking down?
So it did save a lot of money, like compared to, let's say, if you just looked into AWS pricing or like the billing summary, it really showed that we on average saved like 60, 65, sometimes let's say 40%. It really depended on the time of the year. But the problem was that at some point when we reached, I don't know, 20 or even more instances or like containers that we wanted to run in production, we just got like some error from AWS. And basically what it meant is we don't have this capacity for you now. And yeah, like, it works well. It was cheap, but there was no option to, for example, say, okay, I want to use spot instances if they are there, but if they are not, I want to use something else. So what you can do is you can basically configure it in a way where you have a fixed number of instances on the non-spot instances and a fixed number of the spot instances, plus auto-scaling on both if you want to, but there's no like built-in fallback mechanism. And that was really a deal breaker for us.
Now, weekly outages, despite trying everything within ECS, but production reliability wasn't actually your first reason for exploring Kubernetes. What initially pushed you in that direction?
Yeah, so we started with Kubernetes mostly because we were using GitHub Actions and are still till this day. I highly recommend it. And we're using it for a lot of things, but most importantly, building the application Docker image, running the tests, all sorts of tests like end-to-end tests, unit tests, integration tests, and also some other, let's say, less important things. But the problem was with the end-to-end tests that when we hit, let's say, a certain level of complexity, so like our end-to-end tests start the application, Redis cluster, Elasticsearch, some tools, like some sidecar tools next to that, and also the browser itself to run the end-to-end tests, we basically ran out of resources. So what we had to do is we had to switch to the GitHub larger hosted runners, and we did. And it was fine, as in it was working, but it became really expensive at some point, mostly because the tests were often slacking, as in it felt like the containers we were given or like the containers that were running our end-to-end tests were very different in terms of resources. Sometimes we got a very fast CPU, sometimes we got a really slow one, and sometimes the end-to-end tests took 20 minutes, sometimes it took 60 minutes. And because of it, we really had to do something about it. And on the other hand, when we just tried to self-host the Actions runners, it works really well because we can just select the node type and the CPU, RAM, and whatever, and just do it. But the problem with the self-hosted ones was that they were not auto-scaling. So for example, we had to pay for the weekends or the nights when nobody was working, so no tests were actually running in there, right? So what we did is we set up the GitHub ARC, so like I don't remember the full name, but it's like GitHub Arc for the GitHub Actions, basically like an operator that actually self-hosts the GitHub Actions containers or like the runners, and then scales it depending on the amount of tasks you actually have queued in your GitHub Actions.
So CI/CD runners were your way into the Kubernetes ecosystem. And once you saw the potential, what did the full production cluster architecture end up looking like?
So what we did at first was the entire observability setup. So we set up the basic tools like, I don't know, Grafana, Prometheus, Loki at some point as well, and wired it up with like the Nginx, Gateway, and like all of these tools around it, and then started with the basics. So we started with the sidecars at first. So Redis for cache, some sidecars that I was mentioning earlier with connecting the data here and there, and then the actual Docker container with the application itself. And we actually did it in a way where we can actually easily replicate our environments, because we have at the moment 6 testing environments plus staging plus some more. And we just wanted to make it in a way where we can actually play with the configuration between the environments. So for example, some of them have more CPU, some of them have more RAM, some of them have, I don't know, a different autoscaling configuration. And based on that, we just had our basis for the application to work. And at some point we tried with the production, and it was basically as easy as creating another environment for the production. But then once we did that, there was also a lot of tooling needed to actually make it happen, right? So for example, we have the Argo CD for the deployment of the application. We have Flux for like GitOps of the configuration. Like for example, if you want to update Grafana or Prometheus, we also have to do it somehow. So we have Flux for that. And there's like a lot of different tools in there, like, I don't know, Docker image cache, things like that.
You're running, and I would say this is probably the first time we've seen this on this podcast, you're running both Argo CD and Flux for GitOps, which might seem redundant and certainly a way to spark a lot of debates about preferences in the audience. But what's the reasoning behind using both?
Yeah, so the thing is that our team has a couple of people who are, let's say, more versed with infrastructure in general. And those people are not, let's say, they're still afraid sometimes to touch certain points, like certain versions, but they are aware of the consequences and they know what to do if something goes wrong. And on the other hand, we have people who are just playing with the application and they want to, for example, release a new version, or they want to change some configuration of the application. And those people have different needs. So for the first group, we have Flux, and Flux is as easy as commit push and it works. Argo is the same, but in Argo you still have the UI. And in the UI, we just log in the developers, actual developers, like even front-end developers or full-stack developers. They just go into Argo, they can see the configuration, they can see the phase of the rollout, for example, how many containers are there, on which nodes they are, if needed, to debug some things if needed. And then they can also go into like the configuration of the service, change, I don't know, environmental variables, for example, right? They can just do it by themselves without looking into the code, without actually understanding all of the YAML files underneath. They can just do it in the UI and it works for them.
With this tooling in place, you had 7 non-production environments plus production to migrate. How did you approach the rollout?
So for the test, it was easy because we could just switch off the, I don't know, some test server and just like start it new on the Kubernetes, switch it on, switch it off on the ECS, and then switch the DNS. And it was as easy because we don't really care about downtime on the test environments. But then when we wanted to go for the production, what we did is we set up both of them together, switch the DNS, and then in a way force the production to scale down instead of just turning it off. So we didn't remove the cluster, we just scaled it down more and more. So the customers, so like the clients, the users, were reconnected to the Kubernetes cluster. And it worked quite well until it didn't, because we made some typos and some issues. Like we had some issues basically with the configuration, because we just copied a test environment and some of the environmental variables were incorrect, some of the autoscaling rules were incorrect. Like for example, we had too few maximum number of containers. Like some of the configuration were also copied incorrectly. Like for example, we made some typos in the environmental variable name, which resulted in some containers doing double work because they were just configured as a worker and API gateway, for example. So there was a lot of hassle, but I would say that's kind of expected if you switch platforms that different from each other. And one more thing that actually was an issue, let's say a couple of hours after we switched everything, was that, first of all, we had some problem with firewall because on ECS, we just used the default. We didn't set up anything additionally. And in here, we just went with the, I think it's mod secure or something like that in Nginx. And it was working quite well. It was really nice. And we just went with the, let's say, strictest possible settings, which turned out to cut off like 5 to 10% of some production traffic. Not all production traffic, but some production traffic. And we didn't really see it because we just assumed there's always some noise. Like we just assumed we always have some requests against the firewall that were rejected that we just didn't see before because we didn't got those metrics. And now we just saw them, so it was fine. But then it turned out that this was actually a third party failing to call us properly because they were just had some obscure HTTP headers that the mod secure just rejected. And a couple of weeks later, we also realized that we forgot about the VPC peering configuration with our database. So we just paid, a couple of hundred extra for the traffic. But yeah, that's the price.
Non-production went smoothly, but what happened when you switched production?
Yeah, like as I said, all of those things with configuration, performance, VPC, like all of those just hit us, let's say, at different rates. And yeah, like overall, it took us a couple of weeks to, let's say, finish and ease it off. But like the actual, let's say the actual switch, it was just like 5 to 10 minutes really to move all of the customers, like all of the connected users from the ECS cluster to the Kubernetes cluster. Because I didn't say it earlier, what is important in here is that we have a very, let's say, strict distinction because we have some containers that are serving the API requests, like GraphQL, REST API, kind of stuff. And then we have some containers that run the cron jobs, and those are easy because they don't really got any requests incoming. They just talk to the database, execute some third-party calls, things like that. And then we also have WebSocket containers. And those were the hardest to migrate because those are stateless. So whenever we scale down and people are reconnecting, this is incurring some additional costs on the containers that actually got the traffic because they have to initialize the connection, they have to fetch them some data into memory, and those were impacted the most. Because from the API perspective, you just got, let's say, a separate ECS cluster that happens to be on Kubernetes, so that was easy. But for the WebSocket ones, people were just like reconnected over and over for some time.
In ECS Fargate, you just specify CPU and memory abstractly. How did you figure that out for different instance types that were causing the performance problems?
Yeah, so at first with ECS, what we did is we just tailored it to whatever we needed. So for example, we saw that we never go to like a full CPU. So we just went, for example, for 0.9 CPU. And we saw that we never went over, 3 gigabytes of RAM. So we went for 3 gigabytes of RAM instead of the maximum 4:1 ratio. And it didn't work because it also affected the availability of the resources. So what we saw is that if you max out the RAM given to a single CPU, it was much better in terms of availability of the resources from AWS perspective. So what we did is that at first we just maxed out the ratio. So we went from 1 CPU to 4 gigabytes of RAM, and it was fine. And then we just copied it to Kubernetes. So we just said, okay, 1000 M, like millis of the CPU and 4000 Ms of the memory, or like 4 gigabytes of memory. I don't remember which one is it in Kubernetes. And we just did that. And it was, let's say, our entry point. Like that's how we started with scaling everything. And then we were just playing out with, okay, do we want to have the burstable instances? Do we want to go with the, C-type instances, M-type instances, all that stuff? And it took us some time to play with it. And what we ended up was, we are basically using Carpenter now. So it's setting up the nodes automatically for us, and it's handling all of the mangling of the actual, what kind of instance is it actually. But what was important for us, we just saw that we don't really have to specify the class, like the instance class or the instance type, the MRC, whatever. But what we do is we just require the Nitro CPU type. So like this is, let's say, slightly broader, and this is like a certain generation of CPUs. And this is enough for us because they are comparable in performance. So we don't really have to go for exactly, I don't know, C7, G, whatever instance. We just go for a certain type because we have certain RAM to CPU requirements, and then the Nitro requirements, and then everything else is handled by Carpenter.
Beyond the cutover issues, you made over 100 configuration changes in the first month. What were the most critical things that you missed?
Yeah, so the security config, of course, environmental variables, autoscaling, and autoscaling was haunting us for weeks. So we really tweaked it almost daily. So there was that. Then it was also a couple of things regarding the networking. So for example, the maximum header size in HTTP requests, that was one thing that actually popped up at, let's say, surprisingly late stage. So there was that. And yeah, what also was changed quite often was what was configured on the service chart and what was configurable from the outside. So for example, at the beginning, what we did when we were moving to Kubernetes, we just allowed all of the environmental variables to be set externally so we could configure them more easily. But at some point, we just tried to, for example, move them into the application chart. So it was impossible to start the application incorrectly, things like that. Or configuring the external secrets, so we don't have to provide them in the environmental variable, but we can, for example, set them in AWS SSM and then just reference them in the image or like in the service definition. So it was quite a lot of, let's say, nitpicking that we just wanted to do to make it look right and feel right. But at the same time, it was a lot of work regarding the actual traffic shaping. So for example, adjusting the RAM, adjusting the CPU, adjusting the autoscaling, and then also things regarding the Carpenter, like disallowing it to scale down during peak hours or disallowing it to, how is it called? Like to handle the drifted resources during, for example, late evenings, because then we just saw that the response times were peaking because it was collapsing them too aggressively. So a lot of tweaking all of the knobs that we just got because previously we just didn't got any. And now we got a lot of configurations that we just had to review at some point.
And I know you mentioned autoscaling here, but to take this a little bit further, one thing that stands out is using the wrong memory metric for autoscaling. What went wrong there?
Yeah, so the biggest problem was that we just went with the default. And so like we had the HPA configured with both RAM and CPU. So let's say the WebSocket containers were mostly RAM bounded or like the memory bounded. So they just scaled with the traffic. And the API ones were mostly CPU bounded. So they just handled with, like they just scaled with the number of requests. It may seem the same, but like number of requests and WebSockets, it's more about like the number of sessions, let's say. So what was the problem was that the API is not really causing any issues with the memory. So what it does is that you get the request, handle it, and get rid of it. And as we are using Node.js, we have a garbage collected language, of course. So it wasn't really a problem because the memory was just allocated and allocated all the time. But with the WebSockets, the memory is usually accumulated because of the, let's say, internal caches, but also disk caches. And those caches are technically evictable. So like we are using Linux as our operating system in those Docker images. We were able to, for example, SSH into the Docker container or like into the pod and then evict the caches and see that the memory just dropped on the instances and the HPA just saw it, and that was nice. But then the problem was that our application was scaled based on the memory it was using, except for the evictable caches. So it basically hit out of memory errors whenever it was close to the limit. And it was also harder to debug because it was much more visible if the nodes were full. Because if the nodes weren't full, there was some memory, let's say, space that you could just like go over, and it wasn't really killing anything. But then we just had to switch from the, I don't remember the names, but like from the memory to working set or something like that. You just have to figure it out. It's quite popular answer on Stack Overflow regarding those settings, plus you have it in the blog post if you want to.
Now, these are some pretty healthy infrastructure lessons. Your application runs on Meteor.js, which has specific characteristics. What Meteor specific considerations came into play?
Yeah. So the point is that a lot of traffic is actually, let's say, wired through the WebSockets. So the whole point of Meteor is that you're trying to reduce the amount of data sent over the wire. So in normal applications, when you're thinking about real time, you're either polling the server or the server just sends the updates to the client constantly. And in here, the methodology is slightly different. So how it works is that the server has an image of what the client knows, and then it only sends the differences. And to be able to send the differences, the server has to know exactly what every client knows. So it keeps a lot of memory on the server to be able to calculate these differences from the data set or like the database, for example. And this meant that all of those WebSocket containers, like all of them were memory bounded, as I said. And also what, let's say, is the default in Meteor community is that you are trying to have a sticky session because you want to be connected to the same container. In case of, I don't know, you reconnecting or disconnecting, you want to be reconnected to the same container as you were before, because there is a high chance it still has the same cache that was serving you before. And this was a problem for us whenever we, for example, scaled down or scaled up or roll out a new version, because then the people were, let's say, not really spread out evenly. So we just disabled the sticky sessions, and then we also disabled the sock.js emulation because we saw that the the default and raw WebSocket connections worked better for us. And yeah, like sock.js is a great library. It served us for many, many years, but nowadays most browsers just support WebSockets out of the box, so you can choose it directly.
You also separated WebSocket containers from API containers entirely. Why was that?
Yeah. So because they had different boundaries, so like some of them, again, CPU bounded, some of them, again, memory bounded, we saw that it doesn't really make sense for us to autoscale all of them at once, because our API is mostly used, okay, it also used by us, but it's also used by third parties. And that's a big chunk of our traffic. And they have different, let's say, traffic characteristics than us. So our users wake up in the morning and they work for the day and then go down in the evening. But then our third parties are, for example, synchronizing mostly in the night. So we just split those two into two separate containers, like, let's say, the same code, the same container, just different configuration. And on the gateway level, on the Nginx level, they have different traffic redirected. So certain paths, like for example, /API, all of it goes to the API containers, and for example, /WebSockets goes into the WebSocket containers. And then this is handled by two separate groups, and they have separate autoscaling rules. They have different memory and CPU limits. They have different environmental variables, all that stuff.
With WebSocket containers being memory bound, you ran into an interesting memory management challenge. What happened and how did you solve it?
Yeah. So, if you have application, there's a high chance there is something leaking. And the funny thing is that on ECS, it was never a problem, because whenever we were using ECS and we had the spawned instances, we were quite often getting like rotated by ECS itself. So our containers never lived for, I don't know, more than a day or more than 3 days. And then when we moved to Kubernetes, and even though we were using Carpenter to still use, for example, spot instances, we didn't really got rerolled that much often. And that was because the instances, the nodes we were using were not really, I think, that high in demand. You can actually see it on the AWS website. You can actually see for each node type, or like for each instance type, you can see the probability of being evicted at certain time frame. It also depends on the region, like very highly depends on the region. So for some regions, some instance types are not that highly requested. And when we switched to Kubernetes, our containers with the same configuration and the same, let's say, instance underneath to some extent, they just lived for weeks. And this was a problem because even though we release quite often, weekends happen. And then during the weekend, the application was going for, let's say, 4 or 5 days. And then, yeah, the memory was just leaking somewhere, and we didn't got really that much time to work on that. So what we looked into was a different memory, different memory allocator. So we just switched to jemalloc or yemalloc, whatever, and it really helped like a lot. Like it just allowed us to not only get rid of the visible leak, because it just like right now it can run for a couple of weeks without getting restarted, but also it just improved the auto scaling because the default GNU malloc that we had there wasn't really that keen of getting rid of this memory. So the horizontal pod autoscaler, it wasn't really that keen to scale down in the evening. So we had to scale it down forcefully, or we had to scale it down on CPU or time-based, which wasn't really ideal. So with switching to a different memory allocator, and it was jemalloc, like it is still jemalloc, and we are considering memalloc right now, or maybe tcmalloc, like we'll see about that. It just looks like the way you let's say expect it to look. So like it's an actual slope over day and not just constantly growing.
A 20% memory reduction from changing allocators. So looking at the full journey, how long did this take and how did the phases break down?
Yeah, so I would say that the pre-application time, so like the CI runners, so like this GitHub Arc operator, I would say roughly a month, maybe slightly more, because it was all of the initial setup, like creating the EKS cluster configuration, networking, I don't know, Grafana, Prometheus, all that stuff. So that took, I think, the longest, let's say, hour-wise. Then the non-production environments were slightly faster, but it still was roughly a month because we had a lot of experimentation, also some performance testing, configuration tests. We had to also take care of the domains and all that stuff. Then maybe a month as well for production. So like the switch itself, as I said, one morning and it was done. But then those tweaks regarding the security, like mod security, networking, configuration, autoscaling, all that stuff. And then, yeah, months even to still tweak it. Like we tweak it till this day. That is true. We really do, especially whenever we just update some tools, like update Grafana or update something else. We have to tweak those settings because, for example, a different version of certain tools are using different, are reserving different amount of CPU by default. And because we had all of the nodes maxed, suddenly we are having a lot of empty spaces there. So now we have to tweak it by, I don't know, reducing the requested CPU by 20 millis or something like that, because we are trying to max out the instances also on the memory side. So yeah, that's a lot of time if you look at it. That's months. That is really months. But at the same time, except for the beginning, it was, I don't know, an hour a day, maybe 2 hours every 2 days. It wasn't like full months of work every single day of a single person.
4 months is a significant investment. Obviously not as much as a PhD, but still it's a good amount of time for the people involved. What were the concrete results?
So overall, I'm really happy with the fact that it is cheaper. Like it was cheaper back then because obviously right now we scaled up, so it is no longer cheaper, but it will be even more expensive on the ECS. So I would say that the cost reduction was really visible, and it was mostly because it's not like spot instances are cheaper, let's say raw rather than ECS, but it was cheaper because we were able to overlap some of them. So for example, what we can do is like we can have a single instance with 4 CPUs, and instead of hosting 4 application instances in there, we can host 5 in there, and they can just be assigned like a lower number of CPU, like let's say 0.5 or 0.6 CPU. But if they need more, like they need to spike to 1.5 or like 2 CPUs even, they can just do it without interrupting anyone else. So it seems like it is better because our traffic is very unpredictable. So the fact that Carpenter is actually able to squish all of it into nodes, and then I really like the distinction between requests and limits in Kubernetes, and we are really depending on it quite heavily, and that's really allowed us to, let's say, share the leftovers of the CPU that we had.
For teams that are considering a similar migration, what's your biggest piece of advice?
Take your time. Like really take your time. I know it's really promising. I know it is really also costly to have two of them running at the same time. Like from our perspective, it was doubling the costs for like 2 months basically, because we had it running in the background. So it is a cost, but I really wouldn't rush it. And if you have any sort of tests, like if you have end-to-end tests, if you have some integration tests, if you have load tests configure, run everything you have, because there can be some things that you just missed, or the performance characteristics can be different. So maybe you don't need that many containers, or you need more because you're using a different, I don't know, CPU type. For example, you're using a burstable CPU type, then just go for something else. So take your time, test it out. And also, while doing the actual switch, it's much safer not to scale down the previous version that you had. Like if it was ECS or anything else, or like Fargate or like anything else, just let it be. Let's say accept the cost, bite the bullet, let it live for, I don't know, a day to maybe a week even, and just move the users to the new one so they can do it slowly. Like they can just take their time also to be switched to the new instance, and then you have more time to fix it only for those who switched instead of all of them at once, right? So it's also much easier to deal with, 5 customers calling you rather than 500 customers calling you because you just made some infrastructure change.
Radek, what's next for you?
What next for me? First of all, I have to finish my PhD this year, so that's then. And then, like we have a couple of topics regarding, let's say, this whole cluster in Kubernetes. For example, we want to look into Pyroscope from Grafana Labs. Like we want to look into the APM and the actual profiling, like live profiling of the application in Grafana, because we have a different tool for that, and we would like to integrate it in there. Plus, what I'm also interested in looking into, let's say, at some point, is those tools that can monitor the costs of the cluster in real time. Because right now what we do is we go to AWS and we can see the costs, for example, based on a day or two, but we don't really have that granular distinction, for example, how much the CI costed us and how much the production costed us and how much was for the test environments. And there are some tools that can actually track it based on the nodes that you are reserving via Carpenter. So we also would like to set it up and see how it goes.
Okay. And if people want to get in touch with you, what's the best way to do that?
So first of all, I have my email both on my website and on my GitHub. So if you go to any of those, radekmier.dev or radekmier GitHub, you can just go there and just copy the email if you want to reach out. I don't have LinkedIn. There is another person with the same name and last name, but this is not me. So email preferably, and I'm on a couple of Slacks and Discords, but these are, let's say, more. If you are from this community, then you know I'm there, and if not, then just email.
Yep, perfect. Emails what work for us, so I can say it definitely functions. Thanks so much for sharing your time and your expertise with us. Best of luck on the PhD. Look forward to hearing more about that when that finishes, and hope our paths cross in the future. Take care.
Yep. Thanks for having me, and take care.
You're tuned in to KubeFM.